Dispersion. One of the most important topics. Why? Because dispersion tells you about the main idea of statistics, which is called qualitative analysis. For example, in a game, a player's scores are scores of player A and player B. It's like this: 17, 47, 46, 43, 49, 51, 52. Whereas player B's marks are 0, 17, 192, 165, 1, 2. So now mathematically, who is the better player? Obviously mathematically you will get that this player is relatively better because he has a higher average. But with respect to consistency, the first player is a better. So consistency is a very important factor here. Consistency, higher the consistency, lesser the fluctuation. Higher the consistency, lesser the fluctuation. So obviously dispersion, actually this entire thing, this topic which I have named here, this measures what? This measures the fluctuation in a data. This measures the fluctuation in a data. So if I write that fluctuation is 0, if I write fluctuation equal to 0, that means all the values are equal. Until unless the values are equal, it will never be 0. It is measured in very various ways. What are the best way or the easiest way is to range. Range, everyone know that range equal to max value minus minimum value. And we put a modulus. Why we put a modulus? For example, for range we don't have to consider anything positive or negative or something like that. Okay. So for example, if your maximum value is minus 150 and minimum value is 23. So the range is not minus 150 plus 23, that is minus 127. No, this is not the range. Range will be minus 150 minus 23, the whole modulus, that is minus 173. So the range is 173. Okay, so this is the way of calculating range. And then coefficient of range. Next thing to understand here, coefficient of range. They directly give you questions on this kind of terminology. In statistics, terminologies are very important. So coefficient of range is absolute range L minus S plus L plus S. Coefficient of range is okay, L minus S by L plus S, where L equal to max or L equal to largest value, S equal to smallest. L equal to largest and S equal to smallest. These are the two types of thing you need to know. Next is coefficient of range, we have done. Next is quartile deviation. Type 2. This was type 1. Type 2 of calculating this kind of statistical analysis is coefficient of second is quartile deviation. Now what is quartile deviation? Quarter, by this word we can say that quarter means 1/4. So is it deviating from the 1/4 part? How? For example, there are 3 quarters, Q1, Q2, Q3 and Q4. Statistics is mainly concerned about the 3 quarters, Q1, Q2 and Q3. In my lectures on central tendency, I have already explained how to find this Q1 by using the formula L1 n by 4 minus summation of F by Fm into C. This is the thing. So even in Q3 also you can apply L1 plus 3n by 4 minus Fm by Fm into C. If you calculate this Q1 and Q3 and you subtract them, if you just subtract them and divide it by 2, then that will be the value of quartile deviation. So Q3 minus Q1 divided by 2, that will be quartile deviation. The question arrives, will I need to put a modulus over here? Will I need to put a modulus over here? Answer is no, the modulus is not necessary, because always Q3 will be greater than Q1. So modulus will not be necessary. Modulus will not be necessary in this kind of cases. Okay. Next part is how to calculate this quartile deviation, obviously on the basis of this kind of values. One question on calculating quartile deviation with respect to simple formula. Okay. For example, they have given you the values with respect to the corresponding frequencies. Let's see.